Good morning, everybody, and welcome to the first of our manufacturing sessions in our Manufacturing Summit. Before I begin, I'd just like to thank our sponsors, who are Microsoft from a Manufacturing Summit perspective, and Entity Data from a showcase partner of 5G technologies across the whole of the industry city. We have, the manufacturing industry is going through a huge amount of change. We're moving to, we keep hearing about Industry 4.0 and how the technologies are being introduced into the sector to enable it to be able to develop the way that it delivers its services and improves the way that it delivers manufacturing activities. And this is all being driven by, in the world of more connectivity and more data. We're seeing how mobile technologies are being introduced into the manufacturing sector to enable them to improve the services and the capabilities that they provide. We're seeing the use of 5G and better data connections, enabling them to connect their devices and many more devices in real time and with low latency. We're seeing private networks being created to give them the data security and the service which they need to have dedicated connectivity within their sites. And obviously the ability to be able to take away the wires are enabling the manufacturing community to create more cost-efficient manufacturing capabilities. So in this first session today, we're really talking about how do we go on that journey towards a digital industry. So I'm really pleased to say that we have some great partners with us today to talk about that story. First of all, we have Telit. We have Safi from Telit, who's going to come and talk to us about the capabilities that they're making available to the manufacturing industry to enable them to be able to make this transformation into Industry 4.0. And then we have a very esteemed panel which will talk about how do we what do we need to do to go on that journey? What's the roadmap look like, and how can data and connectivity services enable the industry to transform and become more efficient and and enable it to hit a number of its goals that it has as an industry as it moves forward. So I think that's definitely enough from me. So I'd like to introduce up to our stage Safi Khan from Telit to give us an overview of the capabilities that they are providing in the industry.
Thank you very much. Hello, everyone. Today I will be talking about Industry 4.0 and Telit. So very happy to be here. Thank you for inviting us. And our topic today is the road to digital industry 2030. So we're going to look further out in the horizon and to see what is possible in the next 5-10 years. So for some of you who don't know who Telit is or what we do, this just tells you a little bit about what we are and what we do. So Telit is basically a global company. We're based out of Irvine, California, and we are a pioneer in M2M, machine-to-machine products, end-to-end solutions and communications, mostly cellular communications. We also have Wi-Fi, Bluetooth, and GNSS products. In addition to the cellular hardware modules, we also offer connectivity plans like SIM cards and data plans for the devices, for IoT devices. And on top of that, we have the software and platforms, which I will talk about today, which control these devices remotely. So keeping them secure, keeping them maintained and updated, for example, firmware updates and so on. So Telit is always at the core of these IoT devices and offering products, services to our customers, small, medium, large. They are all Telit customers. And we specialize in mission-critical operations, public safety, government, military, defense, manufacturing, medical, all sorts of verticals which are enterprise grade that require high performance and also high reliability. And our plans, our modules, the connectivity and the platforms, they can be bundled together or they can also be offered separately. So you can get a Telit module and then pair it up with connectivity of your own or do the platform by yourself. Essentially, it's a trade-off that you have to make with doing in-house development spending your own engineering resources and developing it. It's a time to market, or Telit can offer you something that's already we have invested into it. So with that introduction, let's get into today's topic. And I'll just get through the animation. Okay, so 5G, we're all heard about the hype, but I'll talk a little bit about what's realistic, what's possible. So there are really three main pillars of 5G. And the first one is called enhanced mobile broadband. And this is the first phase of the 5G deployment that you have seen. Your smartphones have 5G. And now what we do is bring that same 5G feature set to IoT devices through pre-certified global modules or data cards that can plug into routers or gateways, appliances for servers, in the factory for all sorts of machines to be connected. The second pillar of 5G is very important. It's ultra reliable low latency communications. So this URLLC is promising sub 1 millisecond end-to-end latency through 5G wireless connectivity. And then last but not least is massive machine type communications. So this basically means that you can scale the cellular connection to millions of devices without losing the feature set of power consumption, data rate, and coverage and capacity. Some of the key benefits of 5G are basically more spectrum. So there is mid-band spectrum, which is in the 3.5 gigahertz range. And just as a quick example, in 4G, the maximum bandwidth of a carrier is 20 megahertz. And so you can imagine a highway which has one lane of 20 megahertz, but in 5G you have 100 megahertz channels. So you basically are expanding or making your data pipe much fatter, so you can pump and push more data through it. So 5G speeds in our realistic data modules can reach easily 4 to 5 gigabits per second in the downlink and almost 1 gigabits per second in the uplink. And that uplink is very important for factory examples where you have very high resolution, let's say 4K cameras trying to do computer vision and edge intelligence. So those are some really good use cases for 5G applications. Increased capacity comes also from millimeter wave spectrum, and so that's harder to deploy for a wide coverage area, but for a smaller indoor line of sight factory example, industry, it's a very good enhancement where you have actually gigabits of spectrum available. Increased layering and coverage, so the core network and everything it's put together as a new radio. Higher throughputs, I talked about that. Peak throughputs are much higher and low latency. And then what's important is the edge intelligence and the analytics that come with it. So let's envision what a smart factory actually looks like. And these are some of the key pieces which are making this revolution happen, which is that you can remotely sit and monitor pretty much everything about the factory through the cloud. And that's possible with internet or connectivity that is reliable and secure and supports the needs of the requirements such as high speed and low latency and increased coverage. So those are some of the pieces that I will go into very briefly, but if you have more questions after the session, I'll be happy to talk to you offline. So this is kind of a visualization of a 5G enabled smart factory. And the key components here are basically the assets, basically the asset gateway, for example. So if you have large machines throughout your factory floor or your manufacturing facility, each of those subsystems could be collecting a lot of sensor data from the machines through different technologies. And then these asset gateways would aggregate this data, do a lot of edge processing to only send the essential events which are important to the cloud for analytics. And then on the other side is the actual orchestration and how the connectivity to the cloud is made possible through hyperscalers, and how the data is kept secure end to end. And then we have specific products like DeviceWise, which is shown on the middle of the slide on the bottom. So this is a piece of application software that can actually run on premises in any environment like Linux or Windows, AIX. So any of the machines that basically need to gather the critical factory information is processed with this client. And what is important is that overall the cost of ownership and the cost of operating the factory can then be analyzed and optimized. And especially if there is a downtime, it can be addressed very immediately, because an alarm or a trigger can immediately be sent. And so this envisioning of having complete connectivity throughout the floor is basically the wave of Industry 4.0 and the future, how robotics and efficient manufacturing will be leveraging new technologies. And just in my final slide, I'll show how some of these components come together. So some of these components, for example, if you're familiar with what's happening inside today's manufacturing factories, like let's say automakers or aircraft manufacturers, or even like companies that are doing transportation for agriculture, for example, or any other manufacturing facility that is relying on analytics and more computer vision and AI and machine learning, they rely more and more on security cameras, surveillance cameras, or inspection cameras. And so these cameras, if you think about them, they are transmitting data back to the network. So it goes back to having a reliable but fast uplink in the technology. So in 4G, for example, the maximum uplink that we saw typically was, let's say, 150 megabits per second, but you get a big boost and you get up to a gigabit per second uplink. So now you can have multiple camera streams aggregated and sent real time through the cloud for analysis. So some of that analysis can be done locally at the edge, or if it's really heavy duty analysis, you can send it to the server in the cloud and then do much heavier workloads that are needed. And then of course next, the industrial robots. As you can see, they need very, very precise and low latency communication with other robots or with a central system. And so again, 5G can play an important role when 3GPP release 16 rolls out ultra reliable low latency communications. For example, latency is in the, let's say, 20 to 100 millisecond range, but with URLLC and 5G, we will be able to see a sub 1 millisecond latency. Now that can be applied towards, for example, controlling robots remotely, emergency stop buttons throughout the factory for safety. And these need to be very, very reliable. And also need, so if you eliminate the wires, it basically lowers the cost of maintenance. And basically that's the main trend in the industry, where the wires are being eliminated. And you can imagine an assembly line in the old days required a long space and lots of machines. Now you can imagine building a car, for example. Instead of the car going through the assembly line, the car stays where it's being built, and all the machines are wireless, and they come to the car, do their job, and go away. And then the next batch of robots come, and then they build the car and go away. So how is that possible? That's possible because of all the features of 5G that were listed, like the low latency, the reliability, the edge computing, and the higher data rates. So basically that's how we envisioning it, making it possible. Factories also have guided vehicles which are running around at the top of the factory or any kind of a conveyor system. They are also constantly transmitting status and data on where they're going, what are they carrying, what is their next stop. So that is another area where connectivity can give a lot of visibility into faults or just optimizing it. And head-mounted displays, so a lot of the factory workers can have AR and VR glasses which can enhance their training or also diagnosis or any kind of maintenance, so that can be 5G enabled. Handheld computing, you can have tablets or laptops that have connectivity, and then the edge computing and analysis in your gateways is the last piece of the puzzle. So hopefully in a very short time you got a view of how we are enabling the smart industry through our 5G products. Hopefully.
So thanks very much, Safi. In terms of what we just heard there was around all the different pieces of the technology puzzle which come together to make the digital transformation which we'll see happening during Industry 4.0. But, you know, I'm quite excited now about this panel that we've got, because we've got a host of business leaders coming up to talk about how do we turn that technology into delivering the business outcomes which need to happen. And really pleased to have particularly an end customer in Bridgestone come up and share how they're going to be leveraging the benefits that the capabilities will bring with all of this new data and all of these new connectivity opportunities. So if I'd like to welcome our panel up to the stage.
All right, good morning everyone. Thank you for joining us. I'm Eric Clark, I'm the CEO of NTT Limited Americas, and I am fortunate enough to be hosting this panel with an all-star cast. What I'd like to start with is I'm going to ask each of you to introduce yourself, what you do, and then maybe tell a little bit about what got you interested in this panel. When we first started talking about the road to digital industry 2030, why did that resonate and why did that pique your interest about participating?
Sure. Yep. Thanks a lot, Eric. Hi. Good still morning, I guess, everybody. My name is Michael Johnson, Vice President of Digital Technology and Platforms for Bridgestone Americas. So what does that mean? I'm developing technology and platforms and integrations to develop new solutions and services for our business, which leads me to answering your question, why is this interesting for us? The road to digital 2030. We have a transformation within Bridgestone. You probably know us well as a tire company. Hopefully you know us well as a tire company. If not, you know us as a golf ball or golf company. But most of our business is still very much from the tire business, tire sales, tire manufacturing. And we set ourselves off on a transformation to 2030 to really transform our business, to build a business where 40% of our revenue and profits comes from mobility solutions and services on top of a very healthy and profitable tire business that we're proud of. So, and that's all about digital transformation. It's all about developing new value propositions for customers around tire, around mobility, but leveraging a lot of the technology that was described in the session before.
Perfect, thank you. John.
Eric, thank you. John Hoffman, I'm with the GSMA. We're your hosts here, Rich and I and our colleagues, bringing you all together because, as you said, the digital transformation is critical. I'm a firm believer in step changes, so 1 to 2 is a major step change, 2 to 3, 4 was a major step change, and the biggest step change that the world is going to see is the move into 5G. And the 5G around very different applications. So P5G is going to be huge, it's going to be revolutionary, and is going to drive the digital transformation, not only here, but around the world. And it's great to be part of it.
Very cool. I'm Tom Wilburn. I'm responsible for Juniper's enterprise wireless switching and routing business. Before that, for 10 years, I did the same for Cisco. In 2014, I spun out with the founders of a company called Mist to build the next generation of that technology. We were funded by Cisco and Google, and then acquired by Juniper 3.5 years ago. And the reason I'm excited is because any digital transformation has at its core the network.
Yep.
And according to Gartner, and I think our customers, Juniper is leading that transition. So I wanted to be on this panel.
Excellent, excellent. Well, thank you all. And John, I'll start with you. So, well, first of all, congrats on a great event. I think the energy and the excitement around here has been fantastic.
Thanks, Eric.
And as I walk around the show floor and I look at the various booths and read the taglines and talk with people, the innovations and the use cases are exciting. So maybe specifically around private 5G, what are some of the use cases and innovations that you're most excited about today and in the future?
Yeah, well, thanks, Eric. Thanks for the compliments. You know, this is the beginning of bringing stuff back to the U.S. and really driving innovation and leadership. It is going to start in several areas, and manufacturing 4.0 is one of them. What's interesting, I think your announcement yesterday was groundbreaking. I mean, you know, for the city of Las Vegas to put in a private 5G network that is going to allow them to enhance security, to enhance their Parks and Rec program, to enhance, you know, traffic management, pedestrian access, as this is a very pedestrianized city as well. The opportunities are going to be amazing and endless, and I congratulate you and all your colleagues that made that happen. I think it flew under the radar, and I'm a little disappointed in that. But it is one that is going to, I think, be a showcase for the rest of the world. You know, to get government involved in private networks for the benefit of their citizens, for their local economies, for their future, groundbreaking.
Yep.
And I'm not gonna hog your time, but I'm gonna give you one other one. So a company, Hyundai, launched a private 5G network in Japan earlier this year, and they're automating their factory process for their electronic vehicle production, such that they can, you know, as you heard just a while ago, you know, talk about various aspects. But one of the cool things is, if you order one of their cars, you can actually sort of watch it being built, visually, but also mechanically, and all through a P5G network. And those are just, a couple of the great examples that are at the forefront of digital transformation in Industry 4.0.
And both of those examples you gave are all about creating better experiences. And you think about the car example,
yeah.
The experience of owning that car starts before you even get it. And that's something that's really neat to think about.
Yeah.
And if you didn't see the announcement that John mentioned about Las Vegas, NTT and Las Vegas announced yesterday the launch of the largest private 5G network in the US. So we're pretty excited about that. And Tom, that brings me to a question for you. You've been involved, obviously, you just talked about your career, you've been involved in connectivity for a long time. You really focus on connectivity. And you've seen it across, private 5G, public 5G, Wi-Fi, Bluetooth, everything else. How do you see these things all living and working together?
Well, it's exactly what you just said. So think about it. Everybody in this room right now has a device in their pocket that has 3 radios turned on. You have Wi-Fi, you have Bluetooth, and you have 5G. And depending on the use case and the application, your device or you will choose one of those radios. And we're seeing the exact same thing happening in the factory floor. The big transition that we see in industry, and it's really accelerated over the last 5 years faster than I would have expected, is we used to wire up everything. And I'm responsible for a switching business, wired Ethernet, that's bigger than our wireless business. And the conduit, the inflexibility that came with that, it had some benefits and some side effects. What we're seeing is a move now to the wireless factory floor. And that will be wireless writ large. It will be all of those capabilities coming together. So where we focus now is what is the architecture for that network so that it can seamlessly embrace all of those wireless technologies.
Excellent. And Michael, you talked about, most people know Bridgestone as tires or golf balls. but I think probably most people don't realize how innovative Bridgestone is. Maybe you can talk about some of the things that you're seeing, again, not just now, but in the future that you're focused on.
Yeah, absolutely. We're more and more a technology as a service company as much as we are a tire company. Of course, the tire company, very precious and important to us, but so what does that mean? We're really trying to work to solve problems for our customers, for fleets, for consumers, by providing them mobility in different ways.
Yep.
So one of those is, now instead of coming in and buying a tire, you can buy kilometers or miles. So we will actually charge you based on the consumption of that tire. And we do that with sensors and data embedded in the tire, and using that information to understand the footprint of the tire and the wear pattern and wear measurement. And then we can actually bill customers for consumption instead of them having to shell out big cash outlays and capital expenditures. So that's one. But we also work closely to, or intently to kind of optimize the operations of fleets. Every time you see a truck on the side of the road, it's costing that company a lot of money for that idle time and for that truck having that breakdown event. So with that technology, we're able to predict slow leaks in tires, for example, and that's one of the main offenders causing downtime for a truck. And then we can also tell companies, whether that slow leak is going to be critical in hours or days. And we can also help them to schedule service in our service network or another service network at a convenient time, so that vehicle is not having to have kind of unplanned downtime. And this vision came to the company only 3 or 4 years ago. And I think at the time, the traditional tire people thought, that's like Star Wars, science fiction.
Way out there.
That's way out there. But these are business models today that are productive and really helping to transform our company's operations and improve sustainability. Another example is we retread tires, mostly truck tires. And that means that we have a casing that is, you can retread that thing 3, 4, 5, 6, 7, 8 times maybe, depending on the health and how that casing is treated over time. Well, traditionally, fleet managers and dealers would, by policy, decide when to retread a tire. I'm going to retread a tire, twice, and then I'm going to discard that casing and buy a new tire. When in fact, using data, we call it casing durability, we're able to measure the health of that casing and tell, how many more times we can retread that tire, which is driving better sustainability, better asset utilization, better efficiency. It's much more efficient to retread a tire than it is to buy a new one.
Yep.
And all these things, like I said, are already happening today, and it's not light years away. It's happening here and now.
Yeah. So most of what we've talked about so far are things that are happening today. Really interesting, leading use cases today. What are the things that are way out there? And I'll just kind of throw that out there to all of you. What are the things that you're thinking about now and talking about now that, hey, that's a great idea for the next thing coming?
Well, maybe I'll try to be quick, not to consume all the time, but another thing we're working on is being able to understand road surface condition. So if you're a human driving a vehicle and you can see, okay, it's starting to rain, I can see it's going to get slick, I can adjust my driving behavior accordingly. And for autonomous vehicles, we also need to make sure that the car understands the road surface conditions that can change based on different variables. So that's a very difficult one to solve for. And I think 5G will be a key enabler for that, because one of the challenges we have with sensors is balancing functionality and what you can do on the edge with power consumption. The more processing you do on the sensor, on the edge, the more battery you're consuming, and that obviously is a big issue for this value proposition, because that sensor must last for the life of that tire.
Right.
You can't just replace the sensor, when it runs out of power. So that's an interesting one that I think is still something yet to come.
Okay, very nice.
I'm not smart enough to answer that question. I mean, I've been asked it so many, from 1 to 2 and 2 to 3, what's going to be the killer or whatever, right? Technology doesn't solve any problems. People solve problems. People are the visionaries. There are a few individual visionaries in the world, but mostly it's partnerships. So I think the key to the future is all those names that are up there on the industry city, NTT, Cisco, Microsoft, and on and on. It is people coming together, looking at an opportunity and figuring out how best to solve it using technology. And that's kind of where I think we are today. We're at the very, very, very early stages of this digital transformation, especially around the industrial sector. Where will it go? Not smart enough.
Well, Tom, I know you work with some of the leading manufacturers, right? And you're helping them do leading edge things today. But what are they thinking about next? What are their visions?
It's remarkable how the tire business and networking business have parallels. So today we have sensors in the network and AI, and that's what is distinguishing Juniper today in enterprise networking, to where we can tell that a client on the network is having a bad experience before they call IT. And that has meant huge benefits. The world's largest logistics company, the world's largest company is excited about that. It really solves this reactive cycle of I complain to IT tries to figure it out, eventually I get connected again. Where we want to go to is by doing things like injecting synthetic data into the network, is to know that the network has an issue before the client has a bad experience. As the guys at Amazon remind me, the robots in these pictures can't call IT.
Yeah.
And there are problems in networks, and they're going to continue to exist. So, how can we today it's about trying to get IT in a proactive position before the user calls. The next step is before the user experiences a problem.
Right.
That's where we want to go.
And that becomes even more important as we put more technology into the networks. When you think about computer vision and AI and self-correcting manufacturing processes, if you got a network issue, everything stops.
It absolutely does. And part of what we try to do, we were fortunate to work with Tesla, and if you've heard Elon Musk speak, he talks about insane speed, insaneness. And they describe what we do in the network as insane visibility. We're trying to give them an understanding in real time what every connected device on the network is experiencing, so we're not reacting.
Yeah. That
is what it's about.
Good. Michael, you touched a little bit on sustainability when you were talking about retreads, and some of the upside of that is, it's better for the environment. I saw a tagline somewhere out here on the show floor today that said, and I took a note, 5G is fighting climate change. So there are all kinds of use cases where connectivity and 5G and private 5G can help us with our carbon footprint. And I think every large company out there today has made some kind of commitment to that. So how do you see this helping in Bridgestone and ideas that you've seen there?
Yeah, sustainability is extremely important to our strategy and to our company. Our mission is to serve society with superior quality, but serving society is what Bridgestone is all about, one way or another, and sustainability is completely central to that. And we have our E8 commitment, which you know about, so we work very hard on within manufacturing how we source materials. We look at alternatives to less sustainable materials. Rubber trees are only grown in a certain area of the world, and it takes quite a supply chain to get the rubber to our factories around the world. Whereas we have kind of a new emerging alternative to natural rubber called wayuli, which is a shrub that grows in the desert in New Mexico, basically. So. Much more sustainable way to farm that type of rubber. So we look at sustainability from raw material perspective, but also how do we optimize our own operations, and how do we use technology to optimize energy consumption within a factory, obviously to drive better quality, predictive, smart maintenance, and those are the types of investments we've been making in our factories over the last several years. And 5G technology, I believe, will help us take that to the next level, because, we need to, optimize maintenance. So it's cost a tremendous amount of money if you have downtime in a manufacturing plant. So there's a couple of ways to deal with that. One is have maintenance on a schedule and create downtime that's planned so that you're kind of minimizing that impact, but you're still creating downtime, and there's still a cost to that. The more we can use the data from our machines that are measuring vibration and sound and other variables within the data to pinpoint when there may be an event within the factory so that we can go and only perform maintenance when it's absolutely needed, helps to improve the efficiency of our operations and manufacturing, our utilization of energy, and of course our costs, which we can then pass on to society.
Yeah, that's great. And you mentioned that rubber tree, the sustainable rubber tree. I don't know if we've got any racing fans out there, but if you are, you probably know that NTT is the title sponsor of the IndyCar series. And we had a race in the streets of Nashville earlier this year, which happens, Nashville is the headquarters of Bridgestone, who supplies all the tires for the IndyCar racing cars. And they introduced for the first time a green tire for that race that was made from that tree.
Yeah, that's right. Yeah. They integrated that into our. We manufacture those tires in Akron, Ohio, and for the first time we've put that specific product into racing tires.
Yeah. So if you can drive that tire at 200 miles an hour around the streets of Nashville, it looks like it's got a good future.
I think so. Yeah. We just need more of it.
Yeah, exactly. But John, Tom, what about sustainability?
Go ahead.
Yeah.
So sustainability is impacting us in two ways. First, as a company ourselves, we've committed to be carbon neutral for our own operations by 2025. That means our employees and facilities and things like that. The next step for us is our customers are pressuring us to know what our commitment is to sustainability. We want to extend that through our supply chain, all of our contract manufacturers. That's going to take longer. But then the third dimension is customers are starting to ask us, well, what are you doing to make equipment that's more energy efficient? And we're taking our cue from our data center business with the hyperscalers. You know, they're now sensitive to the fact that there's not much data flowing through something and it moves into an energy sipping mode. Now, how can we apply that to the network that needs to be on all the time? And we think there are opportunities. But there's another angle that was interesting for me. Just yesterday, I met with one of the 10 largest universities, and in the room were the usual IT organization, 6 or 7 architects and guys that operate the network. But there was another guy in the room, and this was the facilities guy. And he runs what some people call the OT network, the operational technology network. And what he was interested in is he needs the sensors in every classroom, in every office, to manage the HVAC systems and other things to hit their sustainability goals. So what he was interested in is how do we bring that together so the IT network and the OT network are one network. And that is absolutely where we're headed with it. So we're seeing it both as a company ourselves and from our customers and what they need from us.
Good.
So I lost my pin. GSMA and the mobile sector has been very involved in sustainability, the UN objective, sustainability development goals. They're cool pins. Devin's got one on, but I lost it, and I didn't have another one to stick on. We are the leading sector for the SDGs. The mobile industry has gotten involved very, very early in the process. We have committed across the board to scientific targets. GSMA is a carbon neutral entity as a company. This event is carbon neutral. We've been recognized, and it's not that we've been just starting. We've been doing this for many, many years. We started monitoring our carbon footprint in Barcelona, our largest event, in 2009. We have offset. We've been recognized by Guinness Records 3 times as the world's largest carbon neutral event in the world. It is something that we're very passionate about. We're taking a leadership position and something that we're very proud of. We have a lot of work to do, but we're well on the way to identifying the issues that will drive sustainability for our sector, for our world, and most importantly, for all of us.
Great, thank you. So I want to put one more topic out there, and Tom, I'll start with you on this one. I don't think we can have this conversation if we don't touch on cybersecurity and other risks that come, supply chain shortages, et cetera. How are you thinking about that in terms of 5G and connectivity and challenges that we're faced with?
I think we've all lived through quite an experience the last couple of years. Every company in our industry, our growth has been gated by supply chain, and in some cases exacerbated by cybersecurity attacks on that supply chain. I think, as we look at it, and I think about the automobile manufacturers, not just companies like Juniper, there's a level of geopolitical instability right now where our industry's semiconductor capacity is in Taiwan and China, to a large extent. And that is a significant risk to our industry and the industries we support. So I think what that is going to drive over the next few years, just as we saw a lot of outsourcing in the 80s and 90s with quite a bit of vigor into Asia, I think we're going to see a relocation of some of that outsourcing, probably still predominantly within Asia, but to kind of counteract some of these forces. So I think when I think about the manufacturing environment, and I know Bridgestone, you've got 200 manufacturing facilities for a lot of different reasons, but I think some other industries are very concentrated, and I think we're going to have to see that spread around to take into account that risk. I think that's probably the biggest one. The second thing that we've seen is, as a manufacturer ourselves, in our industry, as long as I've been in networking, we've counted on the cost of producing a component to decrease predictably by 8 to 10% a year. It's just the march downwards. It's not clear to anybody in our supply chain that that's going to continue.
Yep.
And that introduces a business risk. And some of the reasons I think companies digitize is for business agility. Your example of a company not wanting to buy a tire, but to buy consumption of a tire. When you have instability in the system, people favor that.
Yeah.
So just as you're being asked to consume a tire by the mile or by the 30 seconds of an inch, we're now being asked to provide a network as a service and pay for it as you go, instead of buying the equipment that traditionally companies would buy from us.
Yeah.
So I think these are all intertwined, is what I see.
Other big risk challenges that you see on the horizon?
Well, the industry has benefited from economies of scale, global adoption, and expansion, throughout the world. A bifurcation of that causes issues.
Yeah.
We've been successful because we have unified standards, forward compatibility, backward compatibility, sideways compatibility. As we get into geopolitical issues that are attempting to disrupt some of that, it's going to get a little lumpy. And the GSMA is working very hard to minimize those risks. Supply chain issues have been dramatic and will probably continue to be fairly dramatic in the coming years, but it's our jobs, all of our jobs, to make a unifying technology that can be utilized and adopted and benefited around the world.
Yeah.
It's not easy.
No, it's not.
Yeah, I think it's getting, the more things that we're putting out into the wild that are connected, that are bringing data, back into our clouds, to our infrastructure, the more risk we're putting out there. And, for us, we take that very extremely seriously. In the automotive industry and the mobility industry, we're talking about safety and very serious considerations. So we're doing a number of things to make sure that we're doing the right things around security. First of all, it's at the front of everything we do, security by design, from the inception of an MVP or a POC all the way to scale. Secondly, we're partnering with others in our industry, which, most industries you have a tendency to be a little bit insular, but for this it's too important. And partnering on standards and methods for ensuring that our technology and our information is secure is causing us to open up even more. And then thirdly, we've announced recently partnerships with the two largest, cloud services providers, in the world. And we do that in part because we really need to make sure that we're partnering with the right companies, also with NTT, to make sure we're getting the best available technology and processes and services to ensure the security of our technology and our platforms and our applications. So extremely difficult subject, not going away.
Right.
It's only going to continue to grow in importance, and we just have to be diligent and constantly looking for new ways to kind of countermeasure the ever-evolving threats.
Yep, exactly. Great. Thank you. Michael, John, Tom, it's been a pleasure. Really appreciate you joining us on this panel. And thank you all for joining.
Yeah, thank you.
Thank you.
Good job.